The universe is falling apart, and it has been since the beginning of time. This all comes down to one thing: entropy, the measure of disorder. Consider a jar of bees, all safely contained under the lid. Together, they are compact and organized, great at making honey. But now, say I unscrewed that lid. Watch as the bees fly all over the space. Some will go backstage, some will fly underneath the seats, some will even find their way out of here. Suddenly, they're impossible to collect back up, and they're no good at making even a single drop of honey. Suddenly, they're useless. Now, instead of thinking of bees in a jar, think instead of energy in your cup of tea. When you have lots of compact energy, your tea is hot. But let it sit for a few minutes, and just as some of the bees would leave the space entirely, some of the energy will dump tea into the air around it, making your tea cooler. When energy is compact like this, we say that it has a low entropy. And as that energy spreads out, that entropy increases. Low entropy is far more useful than high entropy. That's why an oven with an open door would be no good for your Sunday roast. The interesting thing about entropy, however, is that it's always increasing. Ice always melts. Coffee always cools. And hot air from your oven will always race out when you open the door. I became fascinated with this idea over the summer. It led me down rabbit holes of explanations and examples, and even a few exceptions. If I dropped an ice cube into a cup of coffee, it is in theory possible to observe as the ice cube gets colder and the coffee gets hotter. How could this be? It is possible for more energy to leave the ice cube than enter it. Surprisingly, it's random. It just so happens that there are so many more ways to be chaotic and disorganized than there are to be ordered and regular. After all, there's only one way of having a solved Rubik's Cube, but quintillions of ways of having an unsolved one. Therefore, entropy keeps increasing. As time goes on, the energy in the universe will go from useful to thermal. Entropy will keep increasing. Energy will keep spreading out, creating an incredibly cold and vast universe of impossibly high entropy. This is the heat death of the universe. It will be really boring. But unless physics has something up its sleeve, that is where we're heading. Every day. Don't worry, that's a long time in the future, just as the Big Bang was a long time in the past. But interestingly, entropy is one of the only reasons we know the difference between past and future. The fact that we can't see asteroids uncrash or cups of tea spontaneously heat at room temperature is evidence that we're traveling into the future. Entropy provides us with an arrow of time. Sure, on the surface of it all, it seems as though entropy is this horrific driving force that drags us through time, leading us to the dull death of the universe. But it's also entropy that allows us to be standing here today, and it all comes from the sun. What the sun provides us isn't any old energy. It provides us with a constant stream of low entropy, compact, useful energy that can be used by plants to photosynthesize and grow, which are then eaten by animals, up and up the food chain, every step of the way, the energy spreading out and the entropy increasing. If the entropy of the universe tends to a maximum, then life offers a way to accelerate that process. It has even been suggested by scientists that life itself is a direct cause of the second law of thermodynamics. Entropy is responsible for so much. And by that, I mean literally everything. From black holes to supernovas, to the sun, to the earth that we call home, to you, sitting here today, to the arrow of time itself. It can all happen because entropy began low and has been increasing since the beginning of time. So, the next time that you enjoy a warm cup of tea, make use of the low entropy that you have before it goes away. Thank you.